All right. Can everyone hear me okay? Cool. All right. So my name is Michael Bevilacaque. I'm a software engineer here at Facebook, and I'll be your moderator. So the way this works, that we've collected up the questions from the Q&A in Blue Jeans, from the blog post, from emails from a bunch of places, and I'm just going to work through them and ask them if you have any more questions. Feel free to post them in the Blue Jeans. But I think I'm going to get started with one for the latest talk from the last talk for Akanksha and Richard, which is, at what point in Facebook's growth period did TRA become important? Right, and then how would you think about a similar approach for a hyper growth company partnering with a cloud provider? Akanksha, Richard?
Yeah, sure. Maybe I can start off. So TRE has been around for around 3 years in Facebook, but the value that we get from TRA would have been even more effective, couple of years before that. TRA provides its value because of presence of distributed tracing. The value that we get is how deeply the distributed tracing system is able to capture the data from your system. And if it's not a complicated system, in that case, distributed tracing might not be able to add as much value or add as much observability, and subsequently TRA might not be as helpful as well. However, the moment the system becomes complicated enough, complex enough that there are multiple systems interacting with one another, and it's very hard to reason about the QPS or the resources being used in a single service being driven by different products, that's where TRA definitely becomes helpful. So it depends quite a lot on the complication of this, how complicated your architecture is. But distributed tracing and TRA, both of them are able to provide their value, quite a significant value, the moment things become very hard to reason about by single view systems.
All right, thanks so much. So the next one is going to be for Lohit, and this one is really, the question is that I would like to know a little bit more about the various trade-offs around the cost, ease of use, and real-time aspect of the queries involved, right? The overall design choices, that went into the particular stream processing system.
Yeah, sure. Thank you very much, Michael, and hello, everyone. Yeah, so as you saw in the talk, like initially for us, everything was like one system. As we broke it down into different pipelines and data set, it became very clear and more flexible for us to say, okay, very important data sets can be done in a streaming way. So the streaming pipeline cost is obviously more because of the cost involved in using a high performant streaming ingestion APIs for us right at the moment. But we were able to, by separating out into different data sets and different tiers, we can now balance between like the priority of the use case versus like the cost and such. For like batch pipelines, which are okay to absorb a little bit of latency, we are okay to stream it to another system, while others can be done to the streaming. Yeah. Thank you for the question.
Thank you, Lohit. All right, next one up for Andy. So this one is about how does a service actually request capacity? Does the service owner set it statically somewhere? Is there an ML model that adopts the capacity dynamically? Something else?
Yes, thanks for the question. So it's actually the service owner sets the capacity statically, and the intent of what they set is the amount to handle the peak load during the day. So they set the largest amount they think they'll need over a long period of time, over days or weeks. However, this still we still have lots of capacity requests coming in across thousands of reservations. We're seeing hundreds per day, and this is due to small shifts service owners make and how much capacity they need based on latest like code or products or other understanding. And then also services are always being brought up, and then other services are being taken down and deleted. So it's still a dynamic system that RAS has to continuously optimize for.
All right. Thanks so much, Andy. And the next one is going to be for Ippokratis. You mentioned that you in your talk you mentioned linear scaling being an interesting property of the system. And the question here is just, does that mean power, CPU? Does it include linear power consumption?
You know that the efficiency of servers is has specific characteristics. So I can tell you that since we are focusing on performance, essentially people can do more with less. So by focusing on having very high efficient software, you essentially reduce the footprint that you are using, the hardware footprint you are using to run your workload. So you do see some benefits there as well.
Oh, great, thanks. All right, we're going to jump back over to TRA and to Akanksha and Richard. The question here is, how do you make a decision to discard a trace span, right, and to reduce the cardinality of the samples in order to reduce the cost of the data? Or how does the how do we actually decide what to include or not in the trace?
Yeah, I can take this one.
Richard?
So TRA by default and its general like steady state data collection wants to collect service, or like it wants the traces to go as far as it can and collect data for everything. So by default, we want this to be at as high as fidelity and as much data as we can, because there's no corner in our infra that we don't want to understand. But for specific use cases that want to do experimentation or have a narrowed perspective, they have the ability of selecting which services. Well, not every service is configurable. It's mainly in groupings of like our databases, who are a large consumer. When we make requests to timeline or other product views, they can say, don't go to database, for example, and then it narrows our perspective, and then those traces don't continue as far. So the traces don't actually, like we don't trim anything in our data. If it's in the trace, it goes into our tables. It's more at the trace level that we can figure how far it goes. Thank you.
Great. Thanks so much, Richard. Okay, so I'm just gonna jump back to Andy for this one. So you mentioned solvers a couple times in your talk. Do you have any kind of SAT solvers to compute the best reservations? GRASP, GSAT, WalkSat, something else?
We briefly explored modeling our problem as a SAT problem at the beginning, but we didn't really find that it matched our problem. There are a lot of aspects of our problem that involve numerics around counting how much capacity you're giving to reservations, and then you're also counting these weights of trading off policies. But I will admit that we were a little bit biased. We came from like a background of MIP solvers, so we didn't give it a lot of extra thought. So I'll actually look into these solvers that were mentioned and see if maybe there's something we're missing. But the straightforward basic SAT, it didn't seem very practical.
All right, thanks, Andy. So another one for Lohit here, which is, can you elaborate a bit on what a data set is? A tweet is reflected immediately, so how does the hourly aggregation?
Yeah, this is actually a very good question. So a little bit of background, like what happens like when people tweet, right? So when you tweet in the backend, there are actually that information is sent to like two different kind of systems. One is like an online only system where your tweet is sent to like an in-memory kind of infrastructure where it is reflected immediately for you and your followers. That is a whole different infrastructure and a topic in itself. What the dataset or event pipeline means is that every tweet you do is associated with like a lot of context around it, right? Like, okay, what was the time? What was the time? What was the surrounding tweets in it? Who liked it? Or who saw it? Impressions, engagements, and all those things, right? So there are a bunch of information, data-rich information collected with that. Those form something called as an event, and that event is now sent to and that this is happening across all the users, across all the services, right? So the goal is to make sure that you can aggregate all of them so that you can now build analytics and then machine learning models on top of this rich data. So that is what we call as a rich data set. Think about it as like if you are querying like a large table, and the table has information of all the users, all the tweet, and then you are running some analytics. So that becomes a data set for us. Yeah, that is the difference between like what a data set means and like what a tweet.
Great, thanks. All right, another one for Ippokratis. What kind of telemetry tools and data do you use to identify performance problems and bottlenecks?
That's great. We use all sorts of tools, but primarily we instrument the code ourselves. So every developer, when they are sees building a feature or something, we make sure to put enough telemetry into the code so that we can go back and verify how it is performing, and etc. The interesting thing is that we have all these logs that we generate. Lohit knows better than us how to do log management, but we take all this data, we load them into a Redshift database, and then we can run our own analytics on top of that, and we can do slice and dicing and all sorts of analysis to identify and correlations, hotspots, and for example, how many SQL keywords, what is the frequency of the keywords, what type of joins, the sizes of the commits, all sorts of telemetry. We load them there, and we make it available to the developers to go and analyze their features.
Okay, great. Thanks. Thanks so much. All right. So here's another one for Richard and Akanksha. Can you elaborate a bit on the process used to eliminate bias and the sources of bias in the data?
Sure. Okay, so I guess me and Richard, we can answer it together. So let me explain about what kind of biases ends up adding introduced. That it changes quite a lot. Primarily, trace starting overhead is much different than trace continuation. Because at trace starting, you have to actually decide whether or not you want to start a trace or not. Then there is some sampling decision that you would want to take. So that mechanism itself, that step itself ends up adding overhead. And trace continuation overhead is also something that will be added to the request. And if you're trying to understand the cost of that request using the data that TRA collects directly, then you have to also take into account that this cost has tracing overhead added to it. Additionally, different instrumentations have different overhead added to them. It's primarily because of the language specific way the SDK itself has been designed. The overhead of tracing in different SDKs is going to be different. And we have to take that into account as well. Richard can actually elaborate more on how we eliminate the overhead now.
Yeah, so I'll first dive into trace starting overhead. I was just looking for a marker because it would have been great to visualize it. But what we do is we basically plot on a scatter plot the number of service calls in the trace and the total CPU that was used on that trace. So we get this bar, it's all over, and then we do a linear regression, which basically tries to identify what is the static constant cost at 0 service calls. So we plot all of these individual data points, do a linear regression, find the 0 intercept, and that gives us almost like a static, what do we do if there are no costs or no calls made? And that is our considered trace starting overhead. And then we just eliminate that from the trace starting data point itself. For service-specific continuation, because we're not looking at the policy, deciding whether to do it, doing the coin flip, it's really just check for header if found, create event, and submit. So it's a little more consistent. What we do is we create dummy services that basically will run some dummy code with that set or that style of instrumentation. And then we run that same dummy service while being traced. And we compare the delta in that cost to establish what the like instrumentation specific overhead is for continuation.
Cool. Thanks so much, Richard. All right. Next one is for Andy, which is as requests come into RAS to get new resource allocation requests, do you ever move existing services from assigned servers to other servers?
Yes, we do reassign servers. As in one example, a new request could come in that wants a very specific type of hardware, and it may not be freely available in the pool, but other services might be using that hardware that don't necessarily have to use that hardware. This is actually quite common. And in this case, RAS will strive to fulfill capacity for everyone and reassign that hardware to the reservation that specifically must have that hardware according to their requirements. RAS does model this with some penalty. There's a big penalty associated with yanking something from another service. And there's a lot of online details or once RAS makes its reclaim requests, there's a bunch of other systems that deal with the intricate details about how to drain something safely. So the service still has the ability to have the final say on when that capacity is given up, such that, so that we don't harm some on the service that we're taking capacity away from.
Great, thanks, Andy. All right, another one for Lohit. So what about the cost of streaming pipelines compared to batch pipelines? Are they more expensive from an infrastructure point of view?
Yeah. So one key difference for us is like the way we are modeling the streaming pipeline versus batch pipeline was like most of the infrastructure we had built to support the batch pipeline was in-house based on open source technologies, like years of like optimization and such, right? So the streaming, we are like trying to utilize new cloud features such as cloud data warehouse or data flow or streaming ingestion API, which have a little bit more cost. At this time, we are like more focused on getting the functionality out and then making sure that we can solve these use cases for near real-time stream delivery. And then we'll come back to the optimization as well. So for now, streamings are more expensive than batch.
Thanks so much. All right, next one is for excuse me. Next one's for Ippokratis. This one is, given that you generate code per query that you then compile and execute, how do you deal with the potentially high compilation overheads?
So that was quite. It is very interesting. We take advantage the fact that there is a lot of repetition, a lot of commonality in the queries customers execute. Like there are that many tables with 4 integers, with 5 integers, or whatnot. So what we do is we generate the code, and every time we have a query segment that we have not seen before, we generate the code and we cache it. We cache it locally to a Redshift compute cluster, but we also cache it externally to a global caching layer. And then any other cluster in the fleet, if it sees kind of the same query shape, first checks locally in the cache. If it doesn't find, goes to the global cache and very likely to find it there. By implementing this global cache, we were able to improve the compiled code cache hit rate from being 99.5 to 99.95. So we added a 9 there. And actually, the intuition behind that is kind of the pigeonholes principle. There are that many different questions people can ask. So it works quite well.
Great. Thanks so much. All right, we've got about one question for each speaker left. So this is, we're gonna go through those and then we'll call it a day. So the next one is for Akanksha and Richard. And this one is, how do most users actually interact with TRA?
Most of our, so at the baseline, TRA as a product is a data set, and our users can interact with it in quick slicing and dicing fashion through some data set UIs that exist here at Facebook, as well as some dashboards that we've built. But most of the users and most of our automatic use cases do so with ETF pipelines or direct SQL queries. And so it's really just a data set. You can query it, and we're working on more formal visualizations for easier and approachable slicing and dicing.
Great, thanks. Next one is for Andy, and it's what happens if a failure domain is in maintenance when another failure domain goes down?
Sure. So we do build that extra capacity for every reservation to have to make sure they have capacity despite any single failure domain going down. We did make a conscious decision not to buffer twice that amount of capacity. It's a gigantic cost, and the drawback is that when there is one of these large planned maintenances, and then we observe that unfortunate failure of another failure domain, we are investing in processes to back off the maintenance as fast as possible and get that capacity back online, and just deal with, or service owners will have to deal with that situation. It's just worth too much money to do it the other way, where you buffer twice as much.
Great, thanks. So let's see. The next one here is for Lohit, and this one was essentially, why did you use a pub/sub model instead of an open source, project like Kafka?
Yeah. Again, a very good question. So the way we were thinking is like it was the idea was still based on like what had happened with Kafka, like a message, using message queue to collect all the events and then like consuming it in real time. So it so happened that like when we started adopting the streaming ingestion APIs on Google, PubSub was already there. So we just ended up using it because there was very good integration between the Apache Beam and the PubSub on Google compute platform. But the way the software is designed, it's basically a thin shim layer. So you could plug in any kind of message queue, be it Kafka or PubSub underneath. It's just a configuration change. Then we can easily swap between them. In fact, internally, we do use Kafka when we stream those events to Kafka. Good question. Thank you.
Cool. All right, thanks so much. All right, final question of the day for Ippokratis. And this one is, how do you gain confidence on your physical schema recommendations, the automated physical schema recommendations?
So we kind of have also, first of all, we use telemetry. We monitor the workload of the customer. We see, this user is always joining this table with this other table. So we go and potentially may do a physical change to align them in a way so that we can do collocated joins. We don't have to put shuffle data into the network. So we can measure that. So we gain some confidence by measuring pre-execution and post-execution. The other thing is that we also ask our customers. So whenever we have these recommendations and customers do apply it, we go and tell them, how do you feel about that? And you know, having the human in the loop there to get some feedback is also another very strong signal, and that helps us also improve our algorithms and etc.
All right. Great. Well, that was the last one. So, just again, a huge thanks to all the speakers. But yeah, I think this is pretty much a wrap. Lenny?
Yeah, I will just reiterate the thanks. Thanks to all the speakers. Thank you, Michael, for handling the Q&A. Next week, we will have a topic of reliability and testing and another set of interesting talks. So definitely recommend dropping back by next week if you're interested. And thanks everybody for attending. See you all next week.